Intelligent Transformation, How Operators Can Build 5G-Ready Networks Today. Sponsored by Affirmed Networks and Juniper Networks. Before we begin, I wanted to cover a few housekeeping items. On the right-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green resource list widget. Towards the end of today's presentation, we'll ask for your feedback. A survey will pop open on your screen and will only take 1 minute to complete. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Heavy Reading Senior Analyst Gabriel Brown. Gabe?
Thank you, Stephanie, and hello everybody. Welcome once again to today's webinar on how operators can build 5G-ready networks. Thank you all very much for coming. We certainly appreciate your participation today and hope you find it useful and informative. In this session, we're going to be discussing how operators can build 5G-ready networks, focusing really on the mobile core and the underlying IP services network. There are, of course, several interpretations of what 5G-ready really means. In the session today, we're sort of looking at it in the context of an industry, a situation where the industry vision for 5G and some of the associated sort of performance requirements are now in the round pretty much established. So we're going to be looking at how a 5G-ready technology strategy can help progressive operators prepare for early and rapid service launch in a way that will optimize their investment in mobile core and IP networking and services over the next 3 years. My name is Gabriel Brown. I'm a senior analyst with Heavy Reading, where I lead our mobile network coverage. I've been looking at wireless packet data networks since before GPRS. To give you a bit of background, I'm also your moderator for today. I'm joined by our 2 expert speakers. First of all, I'd like to introduce Ron Parker, who's Chief Architect at Affirmed Networks. Welcome, Ron. Thanks for joining today. Could you just say a few words about yourself and company?
Yeah, thanks, Gabriel. Yes, I'm Ron Parker, Chief Architect at Affirmed Networks, and Affirmed Networks is a leading supplier of virtualized packet core solutions.
Good stuff. Thanks, Ron. And then we also have Phil Lamoureux, who's a mobile network architect at Juniper Networks. Welcome, Phil.
Thanks, Gabriel, and thank you, everyone, for joining us today. You know, as many of you know, Juniper Networks is well known in the industry for routing, switching, and security solutions. My role at Juniper Networks is as a mobile network architect and helping our customer mobile network operators and the account teams understand the forward-looking trends in the mobile industry and bringing Juniper technology to bear so that they can operate their networks in an efficient, reliable, and secure manner. I have a long history in the mobile industry and spanning 2G to 4G, and now I'm very excited to be working with Affirmed and extending our reach into 5G. So thank you.
Okay, good stuff. Thanks, Phil. And just for anyone in the audience who wasn't aware, the Affirmed and Juniper announced a technology partnership back in MWC 2016 earlier this year. So just for a bit of background there. Of course, they still, both companies operate independently as well, of course. So a very simple agenda. I'm going to start with a short intro from myself, just a bit of a status update on 5G. And then we're going to kind of take a top-down view of this 5G-ready concept we've been talking about, starting really with the mobile core, where we hear from Ron at Affirmed. And then we'll move on to hear from Juniper to hear about the underlying IP network, what I'm calling IP services fabric for 5G there. We're looking to have about 10 minutes of Q&A. Please submit questions at any time during the event, and I'll try and work them into the flow of the presentation if I can and where appropriate. Also, we'll have a couple of audience poll questions as we go through this, which are similarly at time we can maybe squeeze in 1 or 2 questions. So with that, I'd just like to, I just wanted to show this chart to kick things off. It's from the 3GPP Smarter Working Group, and it should be coming to your screen. There we go. What it shows is service dimensions of 5G networks. I'm not intending to go into it in detail, but really I wanted to underline that it is services that will drive 5G development and of course investment. And it's really critical to keep this at the forefront of our minds as talk about architectures and technology and so forth. In fact, we can even think about services not yet invented yet. A big part of the sort of 5G design criteria is to be forward compatible to services that will emerge, post the initial rollout, post the first specifications and so forth. So that idea of forward compatibility is very important as well. Nevertheless, as I mentioned before, we now have a pretty good idea in terms of the some of the basic sort of service parameters and performance targets for 5G. The vision, as I said, is essentially established, and the industry is now moving into a development and implementation phases. And then I want to say, I think very germane to today's discussion, I wanted to highlight the emphasis placed on network operation and automation. That's the arrow pointing directly up on the chart here. This is especially relevant to network slicing, which itself is a key bridge between 4G and 5G, and really at the heart of a kind of 5G-ready discussion, as we'll see as we go through the material today. Automation then really being critical to network slicing because of the large number of logical entities that needed to be commissioned, provisioned, and managed as you sort of run through the life cycle of a particular network slice. So we could think of automated service orchestration as being a real sort of tangible example of a 5G-ready functionality. Wanted to give a quick timeline. This is obviously quite difficult because it's moving around quite a bit, and people are trying to bring it forward as much as they can. But essentially, this is sort of my view of things as they stand today. Standards development, as we know, is underway. The study phase in Release 13 is close to completion, completed effectively, and the actual specification work is starting soon formally, but really all underway already. We're looking at the first release of specifications in R14. That's due in mid-2018, and then we have R15, R16 to follow, as you'd expect. Important to note that people involved in the specification development obviously have early sight of them and what's being done, and so can already start to work with prototypes and compatible product ahead of sort of formal freeze and publication of the standards. And so we're going to try, so that's one of the things that's pulling the timeline forward all the time. We could start to see things like millimeter wave radio for 5G radio for fixed access as soon as 2017 in some form. Probably limited in scale, but certainly one of the earlier use cases. I then think we're looking at a mobile operation on a 5G mobile operation on a 4G core from somewhere around 2018 onward. Probably sort of demos and commercial pilots and showcases and things like that at first, but coming pretty soon. And then we'll move to what's known as standalone mode, or 5G radio access in mobile mode, working on a brand new core known as NG Core. I think that'll be somewhere around 2019 onwards. And we'll talk about some of these terms, NG Core and such like, as we go through. The really important point is that with a knowledge of the timeline and sort of insight into the process, operators can start to prepare, not just operators, but the whole industry sort of supporting them, can start to prepare for service launch and rapid service launch as 5G technology becomes available. This sort of look forward, this insight allows operators to optimize their investment in core networks, in IP infrastructure and cloud, ahead of the sort of, if you like, the 5G radio development and device availability. And just to sort of put a bit of context on that, if you're thinking about the sort of go live in 2019, 2020, in a sort of any sort of scale to the mass market, you really have to be thinking about how you can prepare now. And if you're spending money, big amounts of money over the next 3 years, it's as well to have that aligned with what we know is coming. So just my final slide before I hand over, and really an example of I think what I've been talking about. Just to sort of set out that the idea here is, I think the foundation of the new 5G architecture is actually going to be in the distributed data infrastructure that will host 5G network functions, 5G service logic, and in some cases content. These edge cloud locations, distributed data centers if you like, will need wide area connectivity, most likely SDN controlled, and that will provide the sort of routing, redundancy, security, and all the other sort of IP-related services you need to bring these centralized and edge cloud locations together. The aim really is to deploy this in some form of a meshed architecture that is resilient, that can scale and is programmable, hence the SDN aspects I just mentioned, and such that this infrastructure will be able to support service-specific network slices. Put all that together is what we're calling the IP services fabric for 5G. Now, a lot of the underlay is not sort of specific to 5G, but it's a sort of very good use case for it, if you like. Then on top of this, 5G is kind of, and the 5G architecture itself is deployed on this infrastructure. And we're going to sort of talk through that over the following sections. But it's sort of based around really two key concepts that we see already coming in advanced 4G network, which is control and user plane separation, or CUPS as it's known. And I mentioned a couple of times already the concept of network slicing. So with that, I'm just going to hand over to our first section, hand the controls over to Ron at Affirmed Networks. Ron, the floor is yours.
Thank you very much, Gabriel, and thank you everybody for attending. So I'm going to talk about the 5G core, and I'm going to talk about it in a way that paints a picture that we're using pieces that we have, we're growing and migrating, and that what we build today is actually 5G ready. So in this slide, we're reiterating what Gabriel spoke of around 2018. We see the next-gen radio represented by the G node B on the bottom left of this picture, still utilizing the traditional 4G core. The 4G core being defined by 3GPP as MME, P gateway, S gateway related items. May or may not use control and user plane separation. That will be a design and implementation decision, but not a standards-based decision. And then as we progress towards 2020, we'll see that the G node Bs of the world start making use of the NG Core, and then eventually even existing 4G radio will migrate to use the NG Core, perhaps after 2020. So that's a recap of what's happening in terms of RAN first and then core in the 5G standards activities. And NG Core itself, which should be painted momentarily, yes. NG Core itself is starting to take shape, at least in broad brush terms, from 3GPP. And here it's represented as the NGCP, Next Generation Control Protocol, or Control Platform. And it's really a recomposition of functionalities that we know and love from 4G and earlier, including mobility management, session management, policy control, authentication, charging, and lawful intercept. So we see a recomposition of functionalities. We're not really reinventing functionalities, but I think there's a strong supposition that in this core will indeed have a separation of control plane and user plane. So if you take the 4G CUPS idea of separating S gateway controller, P gateway controller away from their user plane counterparts, and then you perhaps swizzle in the MME and the PCRF, at some point what you have is the NG control protocol. And with virtualization, this type of recomposition and reshuffling is far simpler than it was when we had legacy type core nodes. Okay, so that's a little bit of a background on what's happening in 5G. So now we're going to get into what it looks like to map this and then how that applies to existing core build-outs. So this slide is a summarization of all of those new pieces shown in the NG Core and their approximate equivalents to existing EPC functions. So I won't go through this in detail, but it's meant to show that we're not really inventing new functionalities, save for perhaps the slice selection piece, the network slice selection function, NSSF, is a new function. But even it has an analog where MME picks up dedicated core capability in order to redirect a session from the default MME to the slice-specific MME. So that just gets formalized in the 5G NG Core. So again, this is really just a reorganization of pieces that we have anyway. Okay, so this is what we call the decomposed core. And this is really an embodiment of the 3GPP's control and user plane separation concept for 4G. And in this case, we're able to take the P gateway control, S gateway control piece and separate it from the corresponding user pieces. The presumption is you would typically deploy the controller in a more centralized location, perhaps right near an MME and a PCRF, and you would deploy more than one user plane instances closer to the edge, perhaps along the CORD initiative, which is central office reconfigured as data center, but some edge site that has sufficient fiber connectivity. So this concept really is deployable now with 4G. The standards are getting there. They're eligible for pre-standard implementation now. The primitives between the controller and the user pieces are defined. The transport protocol is not yet defined, but I think we can look for that to happen pretty soon. Okay, so once we have this, now we can get into virtualization, automation, and orchestration as underlying aspects of a solution that makes sense in terms of building a 5G-ready core. So once you have virtualization, and presuming here that with virtualization you don't have a monolithic single VM type, single container type solution, that your virtualization structure is actually already decomposed into constituent services, at least along the lines of U plane, C plane, and M plane, and sometimes more granular than that. And so what that allows you to do is, given the application or the slice, you can choose the appropriate quantity of those building blocks that fit the call model. So in a wireless local loop, for example, there's little to no mobility, but there's very high throughput. In an Internet of Things example, you've got a huge number of attached sessions, but they're devices, but they're quiescent most of the time. There's relatively little data and very low mobility as well. So with a virtualized solution, you can build out the optimal solution, and you can allow that solution to morph over time as your call model and your requirements change. And here we see that those requirements can be really quite different. So this shows 3 types of slices, and then the center one is intended to show that it's multi-tiled. So you can choose your slices based on technology, or you can choose them on business objectives, or a combination of both. So if you were deploying an LTE-M service for mid-bandwidth connectivity from Internet of Things devices, say security camera uploads, then you might put that in its own slice, and it might be deployed with a traditional EPC style of deployment. But if you're doing massive IoT using 4G's NB-IoT approach, here we see the CSGN node in the center, which is really an optimization for NB-IoT purposes of the MME P gateway and S gateway functions. And there we might have many, many slices because it's expected to be massive IoT. So there may be different business objectives that cause you to want to slice, not just by the technology, but by the customer set or something along those lines. And then in the bottom we show a single NG Core-based 5G slice. So now you've got the 5G radio, and in this depiction you've got the 5G core, which really isn't so terribly different from a decomposed 4G core. It's just pieces are reorganized a little bit differently, and with virtualization that shouldn't be as scary as it might have been without. And then because, as Gabriel alluded to, with 5G, with massive IoT, with slicing, we're actually increasing complexity in some ways. We have more things to manage, more devices to manage, more network elements to manage, more slices to manage. So automation becomes key in taming that complexity. So it becomes very, very important to have a data-driven automation platform at your disposal, not something that you need to wait for your vendor to recode new use cases for you. I think that model doesn't work. It's not agile enough. So it really needs to be flexible so that the operator can define their own business models, define their own sets of vendors, and then build up automated procedures on the fly without having to write any code or having their vendor write any code. And then the last piece of the solution is you've got your network elements, you've got lots of them due to slicing, you've got your automation under control, but now you need one more piece. You need a rich enough feed of data coming from your solutions so that you can troubleshoot your solutions, so you can do business intelligence on your solutions, so that you can provide useful analytics data to your end customers. And this is where virtual probing and analytics come in. If you were to read the NGNM Alliance 5G white paper, in there they said with 5G you can no longer have discrete probes. They're too expensive, they're too inflexible, especially in a virtualized world where VMs or containers can move around for many reasons. So you really need to integrate the probing functionality into the element that's being probed. So rather than having discrete probes, the probing is really just a very rich set of reporting capability that's amortized into the solution itself. And with that, I'll turn it back to Gabriel.
Okay, fabulous. Thank you, Ron. And so just now, as we pick routine speakers, we have an audience poll question for you all. And what we want to do here is just get a view of everyone in the audience, the answer to the question, or how will 4G and 5G coexist in your home market 3 years after 5G launch? Now, obviously, it's somewhat arbitrary, the answers. We don't know when 5G will launch and so forth. So, treat it as, I guess, just a bit of fun. But do you think 3 years after 5G launch in your home market that you will still be in a predominantly 4G market with islands of 5G? Do you think even within 3 years 5G will come to dominate, even though 5G continues to be important? Or do you think there'll be a roughly sort of 50-50 split between 4G and 5G 3 years after launch? That'd be terrific if you could all take a moment to fill that in. While everyone's taking the poll, a quick question for you, Ron. On a couple of slides back, you're referring to an NB-IoT core with a node or a function called SDSN. Could you just elaborate a bit on what that is? I think it's sort of relatively new terminology and for a lot of people. I know you talked a bit about it. Could you just elaborate on what that actually is?
Yes, certainly. So the acronym stands for Combined Serving Gateway Node. And as NB-IoT was progressing out of RAN and into core specification, it was initially a normative node that was meant as the definitive core node for NB-IoT. Later, it became a informative recommendation that said you can continue to do NB-IoT with some slightly modified MME S gateway, P gateway, and that's perfectly fine. But if you should choose to want to really optimize it, if you were to combine MME S gateway and P gateway into a particular fashion, you would be left with this combined serving gateway node. So it's really an efficiency play for the expected huge number of devices that would be served by NB-IoT.
Mm-hmm. And without pushing into a corner, putting words into your mouth, would you expect people to start delivering, as it were, SDSN products? Is that a standalone product?
Well, it'll certainly be vendor specific, but at Affirmed, we are definitely behind the concept of the CSGN, and we think it's an important part of driving toward efficiency for massive IoT, and in particular here, NB-IoT. So absolutely, this is something that's a very important part of our IoT solution.
Yeah, okay, good stuff. Thanks very much. So let's move on, look at the results now. It's just pushed out. A fairly clear answer there. 51% of respondents still think in their market will be predominantly 4G with islands of 5G 3 years after launch. However, a not insignificant 28% think 5G will dominate, even though 4G is important. And then a further, similarly not insignificant, 21% think it'll be roughly 50-50. Ron at Affirmed, and then perhaps Phil at Juniper. Any thoughts on that?
It's perhaps not too surprising if you sum the bottom two. We've got about a half and half split about predominantly 4G or not predominantly 4G. And I think from a building of core networks perspective, this is a good illustration why there's absolutely no need to wait building virtualized EPC networks today, because the technologies are readily migratable into 5G as the business need arises.
Yeah, okay, good stuff. Phil.
Yeah, as Ron said, the coexistence of 4G and 5G shouldn't surprise anyone, especially based on past experience with 2G to 3G and 3G to 4G. And there's numerous reasons for that. But as this points out, I think planning your network infrastructure and as we've termed it here, the IP services fabric, planning it to help that transition, to smooth that transition and coexistence is absolutely essential.
Yeah, okay, good stuff. I think it's going to be very interesting from my perspective just to see, maybe we'll get some regional variation as well. If you think how quickly 4G LTE deployed and was picked up by the consumer in North America. Mm-hmm. That was very fast. A little slower perhaps in Europe, but obviously came on big when it did happen. Okay, so let's move on to our second section here. Phil at Juniper, the floor is yours.
Okay, thank you, Gabriel. So if we think about the mobile, a mobile network today, it's fairly centralized. It has a few features that are consistent across networks. Fairly manual EMS, management, and fairly manual OSS and BSS systems. The security of the network is generally done at the perimeters, the borders of the network. And one of the thoughts there is that as we move forward, as particularly with like network slices and are there needs for security to be more interspersed with the slices? And I'll talk a little bit more about that. most of the functions today are physical. We're in the midst of a migration to a virtual network function type of environment, but it is a transition and has significant implications. The data centers all tend to be fairly centralized, and of course we have separate packet and optical networks. They tend to be kind of glued together, but where we are seeing the trend towards more integrated packet optical type solutions. So, this is where we are today, and just as we're having a migration, or evolution to 5G, that there's a consistent migration to in the underlying networking. Okay, so LTE Advanced sort of began a drive here because of the need to have low latency for X2, right, for things like comp and interference cancellation. So, being able to network X2 interfaces with security, right, with IPsec, tends to drive maybe a network design that is different between the X2 and the S1 interfaces, right? So that sort of says, well, we're gonna push some security functions maybe out further in the network, and that raises the whole question of what else can I push out, right? So, so we're seeing a trend towards pushing out even compute resources, whether we want to call them clouds or cloudlets, mini clouds, mobile edge computing, now called multiple access edge computing, are all trends towards moving compute and cloud capability way out towards the edge of the network, right? And that's what we're seeing here. One of the the kind of the high-level thought about this is that mobile network operators are reimagining their networks, particularly take advantage of the NFV and SDN capabilities, the capabilities that they see cloud providers taking advantage of. They want those same type of agility, flexibility, time to revenue for new services that cloud service providers have been seeing. So that's why we see efforts like Cord and Mobile Cord, that's central office reimagined as a data center, and next generation central office architectures. Okay, but mobile network operators have a bit of an advantage. They have distributed real estate in their networks, right? These old MITSOs, right, that now can be repurposed to become more like data centers. So that gives a whole new impetus to virtualizing functions that could exist in those former MITSOs. Okay. So we migrate to more of an automated control and orchestration environment. We migrate to more of a security embedded in the network rather than at the peripheral, and disaggregation of hardware and software functions, and virtualization, of course, is another trend. The distributed data center, having data centers that can take advantage of existing real estate. And then an integrated packet and optical core with timing, and I'll talk a little bit about that in a minute, all become part of that architecture. Okay, so I'm going to move on. I'm going to talk a little bit now about some of the features of integrated packet and optical and timing solutions. Some of the critical needs here, right, are high reliability and scalability, and that at every level of the network, in this diagram from east to west, from metro access, an enterprise CPE, for example, or enterprise gateways for enterprise small cell installations, all the way up to packet transport core. You need flexibility and resiliency. At Juniper, we believe that MPLS is a good way to offer that kind of flexibility and resiliency. And it gives itself over to network management that's more automated. And when I say network management, I don't mean just alarms and maintenance, but also the scaling, the design, the configuration across wide areas of the network. Right. The integration of optical into the packet core is a way to achieve lower cost and lower power consumption. As bandwidths continue to increase, for example, the bandwidth offered by 5G, that is a serious consideration in the total operating costs of the network. Plus, it simplifies service maintenance operations. One other point here, too, about timing is we've seen that precision timing as a alternate or supplement to GPS throughout the network. So this is PTP, or the 1588v2 protocol, has really become a critical part of any offer of any network design, allowing you the ability to serve, say, certain verticals, for example, financial services that require highly accurate timing, and also the ability to provide reference timing to small cells inside enterprises or venues that don't have direct view of the sky. It's important to make sure that the physical layer of networking can support PTP. Now, just from a distributed data center approach, having a kind of a scale, a range of products that can go from the very small, say, cloud-lit, cloud on a box, all the way up to the largest top of rack and end of rack type switches is critical, right? And having the same architecture, or the same products that can support various data center architectures that may change and grow as needs grow. This is a form of investment protection. So that's a kind of a critical thing to look for when looking at data center products, particularly switching products. In the disaggregation virtualization domain, or that part of the solution of the cloud architecture, it's key that the underlying virtualization infrastructure can support VNFs from multiple vendors. You don't want to get tied into a situation where you can only get your VNFs from one vendor. Again, this is kind of a lesson from the cloud service provider environment. You have to be VNF agnostic, and that even allows you the ability to kind of experiment with the same function, but being provided by different vendors, and you can do your own evaluation. And you may even find that back to the idea of the network slices, that for one slice you may find that one vendor's VNF is a better choice than than in another slice. And the ability to create service chains of functions is an absolutely essential element that you need to look for in your networking, your virtualization and SDN networking. And that kind of gives you the ability to increase your range of deployment options and resulting cost. And just another word about disaggregation is at Juniper we're firmly in the camp of disaggregating our routing and security software from the underlying hardware. So there are cases where the hardware gives you performance advantages, but for other conditions, again, maybe around your network slicing, you may want the ability to try different vendors for the network functions. So security everywhere, and I mentioned this earlier that this is another important consideration in the evolution of your network to 5G. In the past, as I mentioned, security was more of a perimeter affair. Now with network slices that are maybe addressing different market segments or different verticals and different air interface technologies, with the increase in the number of different kinds of devices that will be accessing the network, it just increases the opportunities for security issues to kind of creep into the network. So, a couple of considerations here. One is security appliances that can be deployed as a virtual appliance in different parts of the network, whether it's way out at an enterprise site or at an aggregation node, as well as at a peering site. Those having scale and flexibility is important. Another consideration is being able to automate the security procedures. For example, detecting threats and whether the detection mechanisms are coming from inside your network or peripheral of the network, and generating new policy that needs to get pushed out for enforcement. So there are well-known security feeds, threat feeds. You want to take the external threat feeds, threats that are detected and within your network, and generate new policies that can then be disseminated to the rest of the network. So centralizing and automating the core functions of understanding the threats, but then doing the rollout of policy, security policy, then that needs to get distributed completely through the network. All right, and then the final layer here is automated control and orchestration. So we talk about different underlays and overlays. Contrail is our overlay controller that allows you to set up complex service networking across data centers. So in a distributed data center environment, being able to create networks of services and functions across those data centers is critical, and Contrail is our way of doing that. In addition, we talk about the network underlay control. North Star is the Juniper product for that, and it allows us, allows us to discover and provision various layers and routes through the network with multi-vendor support, and allows us to do network simulation so that we can predict under different load conditions or failure conditions how the network will behave. And it also serves as a path computation entity. So that's another critical part of your next generation IP network, is that it becomes a fully automatable networking architecture. And then finally, you know, everybody needs help with new architectures and new and evolution to new design, new technology, and that's where professional services comes in. So it's important to make sure that you know, the folks that you deal with, that to help, you know, design and roll out a 5G ready network, can give you the professional service help that you need to do assessments, and also, oops, I forgot to push there we go. To perform assessments, help you with validation, onboarding third-party VNFs when necessary, and sorry, I didn't click all the buttons here. There we go. But having a partnership to help you plan, build, operate, and at some point, if you want to have have it turned back over to the network operator, that's all part of a professional services offering. All right. So finally, just to recap, 5 critical pieces to the 5G ready IP infrastructure, and Juniper Networks, together with Affirmed, are ready to provide that for you. So back over to you, Gabriel, and I think we have another poll.
Thanks, Phil. Just before we go to Q&A, we have another poll question for you. Sort of like a moment of truth, really. What we're asking here is, does the idea of a 5G ready network strategy make sense? Again, it's just your sort of best guess right now, not to be taken too seriously. But we're asking, we offered 4 different answers there. Yes, absolutely, pursuing a 5G ready approach. In many ways, yes, but not entirely. The number of uncertainties remain. Parts of it make sense, but for the most part, it's a bit soon to talk about 5G ready for us. Or no, it's much too soon. We have no standard spectrum or products yet. And as before, if you could just take a moment to do that. While that's actually ongoing, I may go to some Q&A already. Actually, and what I'll do is I think I'll go to Phil at Juniper with this one. This is an audience question come in here.
Okay.
Do you see a need to manage mobile core and packet optical networks together? I suppose is the question. You know, is this all under one sort of management system, or how would you see that?
With the architecture that we talked about here, and this is popping up in a few different places, but we're seeing the concept of kind of a hierarchy of managers. I think there needs to be a say information exchange between say a packet optical core and the EPC, right? The next generation mobile core. There needs to be a kind of a data exchange, but keep in mind the mobile packet core is being split apart, right? And if we take the CUPS architecture, what's kind of, I guess, important for the packet core is making sure that you establish the routes at capacity to the destinations that you need. This is more of a wide area network control function, right? So from our perspective, we would call North Star into play here to make sure that we have properly provisioned, properly managed routes from the different parts of the mobile packet core to the transport core.
Yeah, okay, good stuff. And then thanks for Ron. Maybe just bring you in on that point. Just talk about sort of different perspectives on management, and I guess from there you can go to service orchestration as well.
Yeah, well, I think how Phil describes it, we're really talking about SD-WAN and SDN in the LAN, and to the extent they do need to coordinate, it's true, but not as much as you might think, right? So the best routes that you pick and the resiliency schemes you pick for your long-haul connectivity is going to be completely different than you need connectivity between VMs in the data center, and those VMs are moving around, and the connectivity should move with them. I think there are some places of coordination. There are certain use cases, like in EPC, if we're doing mobility enterprise services like enterprise APNs. Those APNs may have their own routing contexts, and therefore there needs to be coordination between the routing on the EPC side, the routing in the on the PE router side, or push down into SDN as Contrail does. I think that's one of the big advantages that Contrail has, is that it has the ability to tightly integrate L3 routing, including L3 routing, to get outside of the data center. So there is a limited amount of that coordination that's required, and you could definitely call that orchestration, but it's not there for all use cases, I think.
Yeah, okay, good stuff. So with that, let's have a look at the result of this poll here. I've been keeping up, just about half the audience has voted now. And here are the results. Does 5G Ready Network Strategy make sense? 33% say yes, absolutely. That's what we're pursuing. 41% say in many ways yes, but not entirely. There are significant uncertainties. I think very much a fair enough point there. 19% parts of it make sense, but for the most part it's too soon. Similarly, a legitimate view. 7% no, we have no standard spectrum, it's far too early. Again, depending on where you are, I think that's also legitimate. However, having said all that, it's very, very positive, I would say. There, Phil, perhaps you first, and then Ron, if you want to comment. That looks very positive for the sort of 5G ready strategies and investment strategy we've been talking about.
Yeah, a third of the respondents said that they were already thinking along these lines, or already, going along this approach, and then another 40% said that the concept makes sense, but the doubt is holding them back, and I think it's consistent with discussions that I've had with operators. And I think there's some consistency there too with the mobile network operators adopting network virtualization overall. I mean, I think there's a pretty consistent.
Yeah. Okay, good stuff. So actually, Ron, rather than have your perspective on that, I'm going to move straight on to the Q&A. We have about 5 or so minutes left. And actually, I'm going to go to you, Ron, first for this question from a European carrier who's asking, which NG Core network functions, for example, PCF, MM, and so forth, that we talked about in your first slides there, would move out of the centralized data to a distributed data center or node?
That's a great question. I think it really depends on the topology that you're building. Probably policy control would tend to be more centralized. Charging support would tend to be more centralized. Lawful intercept would have distributed elements to it, I would assume. And mobility management, it really depends on how we finally come to the definition of that. But mobility management might have distributed components to it, whereas session management would probably tend to be more centralized.
Mm-hmm. And obviously it would depend, I would imagine, somewhat on how big of a market you're in, what distances you're dealing with, and so forth, how many subscribers you have.
It's entirely use case dependent. To make a counterexample, something like NB-IoT or massive IoT and 5G likely has neither the bandwidth densification nor the latency requirements that push you far out to the edge. So there you might decide you'd rather be more centralized.
Mm-hmm, mm-hmm. Yeah, okay. So if you have any more questions, please type them into the question box on your screen. In a moment or two, the evaluation form will also pop up. It'd be great if you could fill that in while we take a few more questions. Phil at Juniper, unless you sort of want to pick up on Ron's point, I'll move on. What I was interested in is how does, when we talk about sort of IP network design, how much of this is sort of influenced by 5G and what we know about 5G right now versus sort of other services and other access types that are also important to carriers and are being deployed already?
I think the principal driver today in deploying new architecture, it really has to do more with the need for the mobile network operators to offer new services quickly, regardless of what the service is, but to offer them quickly, cost effectively, kind of adopting more of the DevOps model, and it's driven by enterprise. It's driven by IoT in general. I mean, without waiting for 5G, and I think it's also driven by the competition from cloud providers. Right? So a lot of those layers I was talking about. Actually, all of the layers I was talking about are in play today, even if there was no 5G on the horizon.
Mm-hmm, mm-hmm. Okay, so Ron, a question. Well, there's a comment really to you here. I'm going to turn it into a question. The comment from someone in the audience: for operators to maintain multiple networks is expensive. The cost per megabyte on 5G will be lowest. Why wouldn't you just move to 5G? I kind of wanted to, I think that comment's an okay one to make. I want to turn it into a bit of a question. When we think about 5G-Ready today, do you think about it in terms of concepts and gaining experience of sort of new architectures and technologies, but not actually deploying, as it were, the functions you're going to actually use for 5G? Or does 5G-Ready actually mean thinking about the technology and the products you deploy will actually be upgraded to support 5G in future? If you could maybe just address that distinction a little bit.
Yeah, I think it's more the latter. I think the products you procure and deploy today will be upgradable. With virtualization, upgradable has more flexibility than with traditional hardware approaches. That upgradability might indeed mean recreate a new VM with a new personality and new code, have it coexist with some old VM for some period of time, and then turn down the old VM. So you do have a lot of flexibility around what you deem an upgrade. And I think this can be done as a single clustered network element that during an upgrade period that lasts for however long it lasts has aspects of both. So I think you're really not stranding investment. I think virtualization is what is the breakthrough there in terms of being able to act now, get your experience with virtualization, get your experience with the new design approaches like CUPS, which will carry forward in conceptual terms to 5G, and really almost whatever happens to the fine-grained details, is certainly upgradable in a virtualized world.
Yeah. Okay. Terrific. So with that, so we just popped over the hour. So I'm going to bring the call to a close. I'd like to finish by thanking both Ron at Affirmed Networks and Phil at Juniper for today's webinar and the material you presented. Thank you both, gentlemen.
My pleasure.
You're welcome.
And then just to close, I'd like to thank everybody in the audience for attending and participating today. We very much appreciate it. Thank you very much, and goodbye.